Hi, Chris McClune here with Fire Apparatus and Emergency Equipment. Welcome to this edition of our podcast. Today, we have Jason Whitmire. He is the Director of Education and Technology for SafeFleet. We're going to be talking today mostly about lighting, which is one of the SafeFleet brands. And Jason, you can refresh all our memories of all the different brands that SafeFleet has. We're going to be talking about lighting. We're also going to be talking about something that really sometimes, depending on what conference you're at, gets people really wound up, and that's electric valves. And just two different areas that SafeFleet touches. So, Jason, why don't you introduce yourself to get us started here, and then we'll jump into talking about some lighting aspects.
Sure. Thanks for having me, Chris. So, SafeFleet, as you mentioned, my title is Director of Education and Technology. And what SafeFleet is, we're the parent company to several brands that are very popular in the fire industry. Fire Research Corporation, better known as FRC, Foam Pro, Elkhart Brass, and ROM Roll-Up Doors. So those four brands live together in the SafeFleet family. And my job is basically to educate everyone, the industry, the manufacturers, fire truck dealers, EMS people, everyone on the product that we have, what we bring to the table, and really just try and better the industry from an industry standpoint from what we do.
So one of the things I wanted to talk about today was lighting. And what we're going to talk about today, although we're talking about lighting, what we're going to talk about applies to, lighting in general, not only, what the products that SafeFleet is responsible for. So, keep that in mind too, and I think that's an important thing. You're educating the dealers and everybody on things that go beyond just the products that you sell, which I think is important. So to get us started, when you are explaining scene lighting to customers, scene lighting specs, I mean, I came in, I think you and I have similar times in the fire service. You might have a little bit more time than me or vice versa. I mean, when I came in, it was halogen, lights on the side of the truck, loud generators, towers that went up with air and took about 20 minutes to come down sometimes, if depending on what it was. It's gotten a little bit more technical now, but sometimes there are terms and such that we use that sometimes people start to use interchangeably, incorrectly. So, what are some of the challenges that you have when explaining scene lighting specs to customers?
So you mentioned I started probably around the same time as you, and halogen was the big thing. And what made halogen easy for the industry was halogen wasn't that different than the light bulb in your house. I mean, they were two different things. One was an incandescent light, the other was a halogen light, but still it had a bulb, you put power to it and it lit up. And it was pretty much easy to define it because there was a direct correlation between how bright is the light and how many watts of power is it using. So if I had a 60-watt light bulb, we had an idea in our house that's about this bright. And then when I went to the 100-watt light bulb, it was a lot brighter, but it also drew more energy. So as the energy went up, the output went up as well. Doesn't work that way with LEDs. So back in the day when we had our halogen lights, they had a lumen output, but no one cared about or talked about lumens. What did it matter? Wattage told me the story. When it comes to LEDs, I can't tell the story with wattage. Two LEDs that have equal output could have different wattage, just based on the way they're managed, on the way the heat shed off of them, things like that. So instead, we really have to look at lumens. Not a lot of people understand lumens, other than it's a number. To further confuse it, we've got raw lumens and effective lumens. That really gets people confused. So I've got an analogy. I like to use analogies to really try and relate to people in the industry and think of ways to think about something. When we talk about raw versus effective, let's talk about your paycheck. And we won't tell everyone here what you make at the magazine, but just in general, think about a paycheck. So if I told you that you were going to get paid $20 an hour and you worked 10 hours this week, you're that kid coming out of high school, you get that first paycheck and you're all excited. I work 10 hours, I get $20 an hour, which is amazing at that age. And I can do simple math. That's $200. You open up that paycheck and it's not $200. It's like $130 or $140 because Uncle Sam took his piece out of there. And other things, if it's a full-time job, health insurance came out of there. That's how it is with raw versus effective lumens. So when I talk raw lumens, we're simply saying the number of LEDs on the board. If there's 8 LEDs on the board and each LED can put out 100 lumens, simple math, 8 times 100, that's an 800 lumen light. And that's how they're commonly sold in the industry. The problem is when you're standing next to that fire apparatus and that light's lit up nice and bright and it's hitting the ground, you're thinking, well, I bought an 800 lumen light, so 800 lumens are hitting the ground. Not true. There are losses in everything. There are losses in the air. There are losses in the lens. There are losses in the electronics. So again, I'll throw it back to an analogy. Think about a nozzle. If we say on a pump panel, I think most firefighters understand or get educated much more on friction loss than they ever do on lumens or loss of lighting. So we know that if the discharge says 160 PSI, that doesn't mean there's 160 PSI out at that nozzle because friction loss is taking it away. It kind of works oversimplified, but it kind of works the same way in lighting. Some of it's going to go away. And that's the difference that you need to look at with the competitors. Now, you mentioned showing someone and helping them understand. So understanding the specs is one thing. We can educate you on raw versus effective lumens. We can educate you on different ways to look at it. Where it really gets frustrating is, I'll throw it back to you. If I'm going to sell you a nozzle and I tell you this nozzle can flow 185 gallons per minute, what are you going to do when I send that nozzle to you at your firehouse?
I'm going to put it on the end of the hose and look at, run some water through it.
Absolutely.
And, I'm going to test it to make sure that I'm getting the right flow. And, hopefully I do if I know what I'm doing back at the pump panel.
Absolutely. Like any firefighter would. And if you're lucky enough to have a flow meter in your fire department, you're going to hook that flow meter up and it's going to show you the facts. Hey, you said this could flow 185 gallons per minute. I hooked my flow meter up to it. I'm getting 185 or I'm only getting 160. Something's wrong. The unfortunate reality is we can't do that in lighting. I can send you the light. There's no lumen meter for you to hook up and say, let me see if it's really putting out what he said. Now, there are light meters on the market. You can go to Amazon and pick up a light meter for $25. The problem is, number one, those are measuring in lux. So lumens are the output of a light in general and what it can do. If you've ever seen a ground plot for a light, you see the readings on the ground around the rig. It looks really neat. I've got this big splash of bright whites and greens and yellows. What does all that mean? Well, those are the lux readings. And that's specifically where the light hits at a point on the ground over a defined space. So it might be, say, a square inch. So over a square inch, there's a certain number of lux. The problem is if you buy that lux meter, number one, the $25 lux meter versus the $2,000 lux meter, very different accuracies. The second thing is that lux meter has a little lens on it. It's a round circle you'll see. It looks like a white bulb almost. If I'm holding it here in my chest, or I tilt it this way a little bit, or I hold it down here, they're all different readings. So there's no really good way for you as the firefighter to take that light and say, all right, you proved, or I'm going to prove that this is putting out what the salesman said. Unfortunately, you have to have some trust there in your suppliers.
Now, another thing, when we talk about LEDs, you've been talking about the brightness and how to measure it, but there's also a perception that an LED will, like an LED light, whether it be warning or seen, is going to exceed the lifetime that the rig will be in service with a department. Is that true? If not, what is the reality of that?
So, I mean, like anything, it's a loaded question. The simple answer is yes, an LED should outlive the life of the fire apparatus. The reality is not all of them will, and it comes down to why. If I treat an LED the right way, if expose it to a lot of heavy vibration. And of course, a fire truck vibrates. But the way we mount things on a board, we protect them. If I don't overexpose it to heat. So if I were just to light up an LED and say, go to full brightness and stay as bright as you can, I have to shed the heat off of it. If I don't shed the heat off of it, eventually that LED will burn up. That's where you see sometimes you'll see on a warning light, especially a couple individual LEDs are gone and all the others are lit up. That means you probably overheated or got an overvoltage situation and fried that one LED. One of the things when it comes to scene lighting that's very important, just another confusing thing to throw into the mix. So we talked about raw versus effective lumens, and I mentioned heat. Well, when we give you a rating on a light, in theory, you should be asking at what temperature is that rating? With some LEDs, when you turn them on, they're really bright. And if you came back an hour later and left them run for an hour, they're dimmer. The reason for that is the manufacturer has a temperature monitor built into that board. And as that LED heats up, if he can't shed that heat off properly, then you're going to lower the output so you don't burn the LED up. That means you've got to look at the temperature. So like, for example, all of the lights at FRC, if we tell you you're getting a 20,000 lumen light, that 20,000 lumens is at 85 degrees C, which is about 185 degrees Fahrenheit. So that's fully heated up. So we're giving you the rating at full temperature. It would never get worse than that. As far as the lifetime part, coming back to your original question, it should outlive it. The cool thing is with a lot of the LED manufacturers on the market, it's guaranteed to outlive it because they come with a lifetime warranty. Most of your LED lights from your big OEMs in the market are a lifetime warranty. So even if something happens, we're telling you it's going to last the life of the rig and beyond. But if for some reason something goes wrong, we're going to back it up and replace it for free.
Now, again, and we've already hit on a few of these things. You know, when we think of LEDs, just even in our own homes, you know, we're thinking them as being low power, long lasting, which we just talked about, and very bright, which we've also hit on. But an important part of the light, the whole unit, is the lens that
Yep.
light is coming through. So explain a little bit about what goes into lens engineering.
Sure. It's a great question, and it's one of the really important things on the light. When I teach classes, a lot of times I throw things back to, and I call it the cheap Amazon light. And it's not a knock on Amazon. It's just a way to refer to it. Quite often in our industry, as soon as you put fire department behind something, the price goes up. We all know this. And there's a reason for that, because most of the stuff in the fire service, you know, if I buy an axe for my house, I'm not going to do to it what I'm going to do to an axe in the fire service. I'm not going to use it the same way. I'm not going to use it as hard. It's different with lighting. When I buy that inexpensive Amazon light and people say, well, why can I get a 20,000 lumen light off of Amazon that's so much less expensive than the one on my fire truck? Well, the first thing is the lens. So if you take that cheap light and you look at the lens, typically you just see a piece of glass or plexiglass. You don't see any kind of optics built into it. When you look at a lens that has a bunch of things that look like fish eyes in them, or a parabolic shape that makes it look bowed or bent, that is all optics that are built in and engineered into the lens. So there's two ways to essentially aim light on a fire ground. One is reflection, the other is refraction. When we had the halogen lighting, if anyone ever had a halogen bulb blow up on them, you had to take that lens out. And anyone who used halogen has had it blow up on them. When you take that lens out, you'll see that lens is just a piece of glass. You look through it, you don't see anything. That glass is protecting the light. So inside of the housing of that light, there were either mirrors or reflective surfaces. So as that light comes out, it bounces around and it's directed to the scene. That works, but it's very inefficient. When we talked about raw versus effective, the output, the industry average, when you go from raw, so if I say you have a 20,000 raw lumen light, the effective for the industry average, you lose about 35% of that light coming out of the lens. So that 20,000 lumen light in reality is somewhere around 13.5 when it gets out to the scene. At FRC, with the engineering we've done through our lenses, we use refraction. So we're moving the light by refracting the light. It's much more efficient. It's much more accurate. We only lose 10%. So if we say you've got a 20,000 lumen light, it's 18,000 effective. And we've posted all of that on our website so people can understand the two. That's where I come back to this lens technology. So through refraction, we can aim that light onto the scene where it's needed much better. You hear us talk all the time about spot versus flood, or a combination of both. When you're evaluating lights, what you really want to see on the fireground is a nice even pattern. You don't want to see a really bright spot here and then a dim spot off to the left of it. You want to see even light across the scene. That all comes through that lens technology and the engineering that goes into it. The lens on a Spectra light head, for example, from FRC is actually patented. That there's a lot of work that goes into creating that lens the way it is. And just bringing it back to well, why can I buy this cheap 20,000 lumen light off the internet and my fire truck light costs so much more? Number one is the engineering that went into that lens. Number two is the heat, because we'd already told you we're 20,000 lumens at 85 degrees C. That cheap light you buy, an hour after you've turned it on, it's going to be dimmer because they're going to have to naturally dim it down or it'll burn up. And the last thing is that really inexpensive light off the internet, that's not coming with a lifetime warranty.
So to round us up here, before I move into the valve section, in recent years, and I'm talking about the last probably 2 to 3 years, we've heard a lot more about LEDs being, I want to say more technological, but that's not really what it is. But we could almost consider the ones that are going on rigs now to be smart lights. Yep. They're programmable now. So talk about some of the circuitry and the boards and this programmability. Do those boards need to be replaced every so often? How are they protected? Get into all that, because when you dive into it, it really is fascinating what we can do with these days.
Yeah, the technology grows day by day. There's so much we can do with these lights. There's actually an awful lot of really neat stuff we can do that we don't do, because we all know that when you get on that fire ground, you just want to turn the light on and have it work. You really don't want to start messing with a whole bunch of things. But as studies have gone on more and more, you've seen some differences where we all know that there is such a thing as too bright. Everybody wanted the brightest light they could get. So there are situations where I might need the brightest light possible. But then there may be a situation where, I get on scene, I'm doing a vehicle extrication. So hopefully if we've parked our rig right and we're blocking the scene, and now we're lighting up that area really bright. Well, by nature, I'm going to turn on all the lights. So even though I might be working off the officer's side of the rig, I've got the driver's side lit up really bright as well. Now, if the pump operator's working the scene and he sees, okay, the extrication's complete, but we're going to be stuck here for a while waiting for the tow truck. So we're going to start moving traffic slowly up the side of the rig. Well, we don't want that really bright light blinding them, because that's causing more of a hazard. And that's how we end up getting firefighters killed, unfortunately. We don't ever see anyone get lost in the line of duty on a vehicle accident where they get run over by a pedestrian. So one of the things we can do is we can dim that light down. That is simple through technology, where we can program it that they can have a switch on the panel and they can just start hitting that switch just like you would a dimmer at your house and dimming that light down. The fact is, there are technologies where we could auto dim stuff, but it gets very confusing on a fire scene where, another rig pulls up and their headlights strike it, and now that dims everything down. And you're saying, well, I didn't want to dim it down at that point. So the technology is there. The key is for all of us manufacturers to learn more. And we're constantly studying what can be better, what can we do to make it more improved, but not to overcomplicate it, because firefighters want things simple. And that's not to say that they're simple. Their job is extremely complicated. But that's the thing, is they don't want to overcomplicate it more than they need to.
Gotcha. Well, I want to move on to our second topic, and that's electric valves. And I've been to any number of sessions where this topic comes up, and I don't think it's as divided as it used to be, but there is still some division about these things. Now, for me, I've mentioned a number of times, maybe to you, maybe not to you, but I've mentioned I joined the fire service in 1993. We had 281 LaFrances then as our pumpers. Everything was manual. We took delivery of 297 Salisbury pumpers, and that was my fire company's first real experience with electric valves. In our case, when we were designing the trucks, we had an overall length that we wanted to maintain. We also wanted to carry a certain amount of equipment, and to make all this work, we had to shrink the pump panel down a bit. And the only way to get the pump panel down to where we needed it to be was to replace some of what probably were manual valves back on the LaFrances with some electric valves. So I know for me, this is going back to 1997, and I probably am going to stop mentioning all these years at some point because probably going to behoove me not to make me sound. I'm not old, but if I do this too much longer, I'll start to sound it. But anyway, so I've had experience with them. I mean, it's almost, I was so young in the fire service when they came in that, I have known little. There hasn't been much that I've operated that hasn't had an electric valve of some sort on it. But right. All of that being said, like I said, that was 1997. And as we move forward, as with everything, and you mentioned it, I think, about the lighting, we have come a long way in terms of reliability. So to get us started on the valves portion of this, what I'm thinking is, talk about the advantages of electric valves, but also talk about how far along we've come considering reliability.
Sure. There's a great history to tell there, and I'll date myself along with you. The first truck I pumped was a 1984 Hahn, and not only did we have manual valves, but the throttle turned counterclockwise, and we all know it pulled a cable that was attached to the engine. And FRC mixed pressure governors. One of the questions we get all the time: can I get a manual throttle? There are no engines anymore that have a cable going to them. Even if it looks like a manual throttle, it's an electronic throttle. So electronics have been coming for decades, as we know. There's a really interesting history to the electric valve. And unfortunately, electric valves have a bad reputation in our industry because most people say at 2 a.m, when the proverbial crap's hitting the fan and it's really going bad, can you guarantee me that thing's going to work? And the answer should be yes. Unfortunately, the reality for a while was no. And the reason was we would take, back in the day, the industry, when I say we, would take an industrial valve that was electronic and say, okay, I'm going to throw this on a fire truck. Well, think about how that industrial valve worked typically. A lot of your factories that have big industrial electric valves, they open up under no pressure, then they ramp up their system and flow water, and then they probably ramp the system down and close the valve off to shut down the pipe. That's the exact opposite of what we do at the fire scene. The first thing we do is we put that truck in pump, and even though we're at idle, we're still spinning that pump at that point at 700 RPM and generating pressure inside that pump. 9 times out of 10, we're going to start to ramp that RPM up before we ever open a valve. So the example I always give is if you've ever been out in a fire scene and you're running a cross lay and someone says, we're going to go defensive and I need to open up the deck gun. Typically, that deck gun's a 3-inch discharge. And a lot of times it was a push-pull handle. If you had that RPM ramped up and there was pressure churning in that pump, you would grab that with both hands and pull that handle and a lot of times not be able to get it open. I've done it myself where you stood on the running board and leaned with everything you had to pull that valve open. And then when you did open it, you caused a water hammer, which wasn't good for anything. But at least you got it open. So all that force that you were seeing and all that force that it took to pull that handle open, that was for that ball valve to overcome the pressure inside the pump and open. When you threw an electric valve in there, that electric valve was seeing the exact same force, but the force was going into the motor. So back in the day, those motors would eventually hit an overcurrent situation and wear out. The gear teeth would rip off and you'd tear up the gear, and it didn't last. The other thing is, on a fire truck, we don't run our valves all that often. I mean, if you run 300 calls a year with your fire truck, I bet you pump it out of fire, if you're lucky, 20 or 30 times at best. And of those 20 or 30 calls, you're probably not running the electric ones a lot. So they sit, and as they sat, they would wear, and they would work themselves into a situation where they didn't want to open. Everything got redesigned about 15 years ago. We changed the motors. We went to a high torque motor that was specifically designed to handle exactly what we see on the fireground. We completely sealed up the electronics. So if you've ever heard of potting of electronics, basically you're taking everything in those electronics and dipping it in epoxy. In fact, if you tried to remove the cap off of a motor these days on an electric valve, you won't get it apart because, number one, there's nothing in there to service. But number two, the screws set into the epoxy and won't come off. That prevents water from seeping in and frying our electronics. The third thing was to know where an electric valve is to operate. There's an encoder in there. That's a magnet that is moving along a switch and looking to see where the position is of the valve. We improved them encoders so that there was no failures there as well. Okay. So in today's electric valve, those fears should be gone. Everything's been redesigned. And it's funny, when I teach electric valve classes, I usually say, hey, I can sit here and preach to you all day and tell you what we've improved. But if you really want to see where we stand, look at the warranty. It's a 10-year warranty on the valve and the electronics. That means we've tested this heavily, and we know that we can stand behind it, and you're not going to have an issue with it. We've completely redesigned this electric valve to work the right way now.
We've been talking about reliability. And when we talk about reliability, we're talking about, repairs and things like that. Now, you mentioned, there's nothing to really service in the valves, but as a service, I think many departments have started to make sure that they include the mechanics or the EVTs who are going to be servicing the trucks when they are putting together their apparatus purchasing committees and making them a part of that committee. When we talk about electric valves, what role what is the importance of having the mechanic involved at that point when you're specifying the electric valves?
It is important, and it does matter. And when I said there's nothing to service specifically inside the electronics part of it. The valve itself can and should be greased. So there's a grease zerk you're going to find on all of those, the gears for the motor that you want to be able to get at. What matters to the mechanic is how to get at it. So you mentioned earlier, the biggest reason to go electric for a lot of people was to shrink that pump house. Tighter wheelbase, better turning, better maneuverability. But every time I do a manual valve, I need a way to control it. So that push-pull rod has to run through. And per the NFPA code, I need to have the push-pull handle within a certain distance from the gauge. So the easy way for a designer of a pump house was just lay them out in a straight line. It looks nice. It looks clean. It also makes a pump house that if I stretch my arms out, I can't reach either side of the pump house because it's so large. And it's really increased my wheelbase at that point. Electronics removes all of those push-pull controls. So it allows us to make it much more compact. It also makes a nightmare for the mechanics because when we talk about valves, they're specifically in the industry, no matter whose valve it is, they're called swing out valves. And what that means is there's 4 bolts that hold the valve in place. And if you remove 3 of the 4 bolts, you can swing it down out of the plumbing and service the seals and the ball inside. Well, the problem is if I compact it between 3 pipes, you can remove all 4 bolts and you still can't pull it out. So these are the type of things where your mechanic certainly can't say, I want to define the location of every single valve inside the pump house, because you'd end up with just a mess of piping inside that would look like monkey bars before you were done. And then your friction loss would be incredible going through. But your mechanics certainly can work with the OEM when they're designing the pump house and say, hey, there's a few things that I'm specifically concerned about. I want to make sure I can get at these things. If you really want to go over and above, grease zerks can be plumbed out to a pump panel so that you could have a common point to grease everything. They make systems that will automatically grease a fire truck that can be tied into your valves as well. So having the mechanics input is certainly important when you're laying it out.
Okay. I mentioned before that, the different conferences that I've been in, it's often divided regarding electric versus manual. Earlier, you mentioned that there are people that want the control knob, because they think it's manual, but it's really not. There really still isn't a cable there. Are there options? Are there options similar, to the knob for valves where you're getting the look and feel, but the reality behind the pump panel is that it's controlling something electric?
There's nothing on the market right now. About 5 or 6 years ago, Elkhart toyed around, and we actually went to FDIC with this, but we never brought it to market. And it's something that we've debated whether we want to bring it back to market. We kind of need the voice of the customer. We made what we called an electric push-pull. So a lot of old school pump operators want to look over and look at that pump panel and say, okay, that one's halfway out, that one's closed, that one's the whole way out. I know that one's fully open. I know that one's gated. When you go to the electronics, they don't have that look and feel. So we played around with a push-pull handle that was actually an electric actuator. So as I pulled it halfway out, it moved very smooth because it was just a slide. But that slide was sending an electronic signal back to the valve telling it to open halfway. That is something that could come back into the market as we get more electronics in if people feel that they need it. One of the cool things that exists today is your electric valve is still going to operate with a traditional controller with some push buttons, but your display. One of the things that a lot of people didn't care for was everything went digital. So when they looked at the pump panel, they didn't have an analog gauge bouncing around that they could say, now I know where my pressure is. Instead, they had a number there. And they didn't like that numeric value. With our Apex controller, we give them the option. You can just do a simple digital readout. You can do what we call a basic readout, which gives you digital, but it also gives you a scale that's showing you where you are. And then if you want to go full bore, and all of our Apexes, you just choose which display you want. But the full bore one is a true analog looking pressure gauge with the needle, but it's all done digitally. So while it's digital and electronic, it gives you that look and feel of a traditional pump house. Now, the one really cool feature that I love in our Apex controller, you've seen a lot of fire trucks. You've had a lot of fire trucks that you guys do articles on, and we've always had the debate on how do you mark the panel. So if someone's determined cross lane number one, we went out with our flow meter, we flowed 160 gallons per minute, we have our nozzle, and that's what that's set up for. And I know that I need to flow that at, let's say, for example, 120 PSI in the discharge gauge. So you'll see someone with a black magic marker, if it's really crude, and they'll write it on the panel. You see charts, which are awesome, a chart laying somewhere. You'll see people take a piece of tape and put a nice piece of pinstripe taping on the gauge that says flow it here. With our Apex valve controller, we have a target pressure window that you can set. So you can tell the gauge to 120 is where I want to flow that at. And it'll bring up a little ghosted window on there. And now you're telling the operator, get the red needle inside the gray window and life is good. Change that line 3 weeks, 3 years down the road, new fire chief comes in and says, I want a line that flows 185 instead of 160. No problem. Go into the gauge programming, which is just some menus, change the target window. So it's very flexible.
Are there any other advanced features built into some of these electric valves and controllers that you can speak to?
Yeah, absolutely. With our electric valves, so every one of our Apex controllers, you can do what we call, I hate to say the word auto, but full open.
Okay.
So traditionally, I would have to stand and hold the green button until the valve was completely open. All of our valves have a shortcut built into them. So if I know I want to go full open, I push the open button, hold it, touch the close, and let them go. Now it will very slowly, it'll stay under the NFPA guideline for slow close or slow open. It'll very slowly open itself the whole way. Same thing with close. If I'm shutting down and the fire's out and I want to close this valve, I hold the close button, I tap the open, I let go, and now it'll go the other way. We also have a preset feature. So every one of the controllers has a preset button on it. So if you've determined that when you're at idle or when you're at your preset, say 1,000 RPM on the governor, if you've determined that crosslink number 3/4 open is the right way to have that valve to flow properly, you can set the preset so you just hit the preset button and it'll automatically open itself to 3/4 of the way. The really cool feature that we're developing right now, and it's not out yet, but it'll be out soon, we're going to call it our Apex Plus, which is an advanced feature for our Apex where it will look at feedback. So if you said, I want 160 PSI on this gauge, you could set that in the gauge and say, go to 160 PSI. The valve would start to open itself. When it hit 160 PSI, it would stop and stay there. Let's say they went up 2 floors with the line. As we know, when you go up 2 floors, you're increasing your friction loss by about 10 pounds. So now you're going to need more pressure. Well, the valve at that point would detect that the pressure has dropped to 140 and would automatically open itself up a little more to stay at 160. So we've really tried to simplify pumping operations at this point through those types of features.
Well, Jason, before we wrap up, and again, my thanks to you for sitting down with me today to talk about these couple things. Are there any takeaways that you'd like the audience to walk away with about either lighting or the electric valves?
So the big thing with lighting, the takeaway that I have with lighting is make sure you're asking the question about effective output. We all in the industry, we have to have a position where we sell from, and we all sell from raw, but our effectives are very different when you look at the different lights. So ask the question. Most websites will tell you the raw and the effective value. If they don't, ask the manufacturer the question. You're not calling them out. You're not being mean about anything. You just want the facts. Mm-hmm. When it comes to electric valves, don't be afraid. We learn from history. All too often, we're trapped by history. So yeah, there may have been problems in the past. Ask the questions and get someone to give you the facts, and then don't be caught up in your fears of the past. I'll mention something in closing, just a quick plug for a site that we just released recently. It's called rigrecon.com, and it's a Safe Fleet site, but it's our place where we're trying to get people to go to learn about fire trucks. So if you're on an apparatus committee, you're getting ready to spec a truck, the whole point of rigrecon.com is not to just be in your face selling you product, but to have a site that you can go to say, I want to learn about all the little components and what goes into them. So on RigRecon, you'll see things we have there, videos, white paper seems to be a bad day. That's an old guy term these days. So it would be more a YouTube video that just talks about a subject and says, here's what you want to look for. And then sure, it's going to tell you what product we offer, but it's also going to tell you, here's our competitor's product that matches up with it. So if you're shopping for something, it's a very nice place for you to go and learn about all of the product that's out there.
That was actually going to be my next question for you, would be what website should people go to learn about this? But Jason, if anyone has a question for you, is there a way they can reach you?
Sure. So first of all, if you go to that rigrecon.com, you can submit stuff through there. But my email address is my first name, last name. So it's jason.witmier@safefleet.net. If you go to any one of our Safe Fleet branded websites, there's a directory of all our personnel, and that'll get you my contact info. It'll also get you your local regional's contact info.
All right, perfect. Well, again, my thanks to you, Jason, for sitting down with me today. If there are topics that we have not hit on this podcast yet, please let me know. I'm at chris.mcclune@clarionevents.com. If you would like to see all of our archived podcasts, they are available at fireapparatusmagazine.com/podcast. So again, this has been Chris McClune with Fire Apparatus and Emergency Equipment, along with Jason Whitmire of Safe Fleet. Have a good one and stay safe. Thanks again, Jason.
Thanks, Chris.